So I did not forget that we left one problem out when we went through the first side of 2.6, and that was this section. Okay, we discussed the line symmetry of these various objects, but we did not discuss their rotational symmetry at all, and specifically whether it has rotational symmetry, and then to state the degree measure less than 360 degrees. So let's go ahead and figure and learn how we go about doing this. Let's take our first figure, which is a star. Okay, it's a 5-pointed star, and we're going to start by considering this illustration, and in a few moments you'll see exactly why. What I've done here is I've drawn a point, and then I have 5 different rays that are all coming from that one point. They all share the same end point, the same starting point in the middle, and they're all radiating outward like spokes in a wheel. They are also, in terms of angular distance, they are equidistant from each other. Okay, so the angle here is equal to the angle here, is equal to the angle here, here, and here. They're all equal angle measures. So my first question to you is, what is the degree measure between two of these rays that are adjacent? Okay, so we're starting out with a circle, right? We have a circle which is 360 degrees. And we have how many spaces between lines? 1, 2, 3, 4, 5. Okay, we're dividing that 360 into 5 equal angles. So what we end up with is 72 degrees each angle. Okay, so 360 divided by 5 is 72. So if we draw a diagram like this, we know that we've got 72 degrees there, we've got 72 degrees there, 72 degrees there, 72 degrees here, and 72 degrees over here as well. Okay, so that's something we know when we're starting out with that. Well, why did I draw this diagram? Okay, let's take another look at this 5-pointed star. Okay, but what we're going to do is we're going to put it on some patty paper. So now I've got the 5-pointed star on patty paper, and I'm going to line up the 5-pointed star in such a way so that every one of its arms lays on one of the spokes. And I'm going to do it just about, that's pretty close to it. I'm going to take a piece of tape, and we're just going to keep it in that position. Okay, and furthermore, I'm going to put a little red dot on this right side here so that we can keep track of where our starting position is. And then I'm going to take another piece of patty paper, this one, and I'm going to use as a center of rotation the very, very center of the 5-pointed star, which is going to be approximately over here. Right about there's the center point. And I'm also going to label this with a little red dot too. So we know that when we're starting out, before we actually start rotating the star, okay, and we're going to rotate the top star on top of the bottom star, they are aligned. Both of them are in the exact same position. So remember the definition of the degree measure of rotational symmetry. That is the degree, that is the smallest number of degrees that an object can be rotated around its center point that makes the object look the same. So let's start rotating this object around its center point. Notice the one that we taped is not moving, but the one that we're moving is sliding above that, the one that we taped on. Now, are they overlapping? No, not yet, right? Got to keep on going, keep on going, keep on going, and now you'll notice just right there, they're overlapping again. Okay, they are overlapping, and notice where the red dot moved to. The red dot went from its original position here to its new position over here. How far did it move in degree terms? We know, 72 degrees. Okay, so the answer to the question in the guided practice is that the angle is 72 degrees. We're going to write that in the paper in a moment, but I just want to also show you how we can calculate as well the order of rotational symmetry. Remember, the order is the number of positions in which the object looks the same, where the last rotation brings it back to the original position. So this is the first position where it looks the same. So let's keep a count. Over here we have one position. Let me just make a mark there. We've got one position. Let's keep rotating it. Rotating it. It's not overlapped. It's not overlapped. It's not overlapped. And then again it is. Okay, right about there. Everything's overlapped. I kind of moved. Let me get it so it's right up against the other one. Good. It's overlapped the second position. The red dot is now over there. And we've gone a total of, the original red dot was here. Now the red dot moved to here. So we've moved 72 times 2, or 144 degrees. Now let's rotate it again. And once again, we have an overlap over here. Okay, now it has moved 72 times 3 degrees, which is 216 degrees. And now we have a fourth position as we rotate it around over here. And finally, the last rotation is what brings it back around to its original position, which would make it the fifth position. We are back at our starting point. Okay, so the order of rotational symmetry here is 5. It went from here, went to here, 1, 2, 3, 4, and then it went back to its starting position again. So let's go back, let's write in these answers. So for the star, the rotational degree is 72 degrees, and we'll just make a notation here that the order of rotational symmetry is equal to 5.